In this video, we are going to look at how to solve problems based on resistive forces. An object falling from rest experiences a resistive force Fr, which is given as negative kV square. What is the magnitude of its acceleration when it is moving downward with a speed of v equal root of 2mg over 8k. So the object is moving down. That's the direction of its motion. So the forces which will act on the object are the force of gravity, which will pull it downwards, and there will be a drag force which will be opposite to the motion, and that drag force will write as Fr. Now it's asking us to get the magnitude of acceleration. So the first thing we'll write acceleration is F net over mass. Now from the diagram we can see that F net is mg minus Fr, because gravity and drag force are opposite to each other, over m. Now Fr is given to us from the question. We can see that Fr is negative kV square. Now this negative is to tell us that drag force is opposite to the motion. So we are not going to repeat that negative when we put it into the formula for acceleration. So what I mean is we are going to write mg minus Fr, we are going to write as kV square, because we already took care of the negative by drawing the free body diagram. So we have shown that the drag force is opposite to force of gravity or to the direction of motion. Now we are going to put the numbers whatever we have here. So we have got mg minus k v square, so root of 2mg over 8k whole square over m. If you open up the bracket, we'll get mg minus k. The root will disappear because you have got a square. So 2mg over 8k over m. The k up and down can be cancelled out. So we are going to get A equal, so let's just make some space here. Okay, A equal mg minus 2 over 8, which is going to be 0.25 mg over m. So what I did is 2 over 8 is 1 over 4, and that's 0.25. You can calculate on the calculator. M is appearing everywhere. You can see m in every expression, so we can cancel out m. So we'll be left with g minus 0.25 g. G means it's 1, so 1 minus 0.25 is going to give us 0.75 g. If you want, we can substitute the value of g. We can get this as 0.75 multiplied by 9.8, and that will give the answer as 7.35 meter per second square. So that's how we can calculate the acceleration of this object which is falling from rest and experiencing force of gravity and drag. Next problem again on resistive force. An object is moving horizontally. The resistive force on the object is given by Fr equal negative bv. At t equal to 0, v is equal to v0. So that means they have given us the initial condition. Find an expression for velocity of the object as a function of time. So we want to derive an expression here. So this is something where we are not having any numbers, and we are going to derive an equation or an expression for velocity of the object. So the first thing, object is moving horizontally, and the only force acting on the object is the resistive force. So we can write F net is equal to Fr. So F net, in this case, Fr is given as negative bv, so we will write it as negative bv. Negative is showing us that it is a decelerating force. It's opposite to the motion of the object. Now, F net is mass times acceleration. We can replace that. Why we are replacing? Because we want to get velocity into the equation, and we know that acceleration can be written as dv over dt equal negative bv. Now we want to get an expression for velocity, so we have to get rid of this d over dt. So for that we are going to write mdv, and I'm going to take dt on the other side. It will become minus bv dt. Now we'll get the v velocities together because we want the expression for velocity. So dv over v, so I'm moving the v on the left side, so minus b dt over, and m I'm moving on the right side. So here I'm dividing both the sides by mv. So we can see that v and v will get cancelled out, so m will be left on the right hand side in the denominator, and here m and m will cancel out, so v will be left in the left hand side. So that's how I get this equation. Now I am going to integrate both the sides, and I'm going to put the limits. So I know that the limit for time is 0 to t, and for 0, time equal to 0, they said that velocity is v0, so we'll write v0 to v. That's the limit for both the sides. Let's just put this down to see it clearly. Okay, now integration, when you do the integration of 1 over v, you can see that v is in the denominator. We are going to get natural log ln v, and the limits we can see it's v0 and v equal negative b and m. They are constant, they can come out, and when I do the integral of dt, I'm going to get that as t. Now ln v minus ln v0, by applying the limits, negative bm, negative b over m multiplied by time. Now using the rules of log or natural log, we can see that negative or subtraction can be converted into division, and we can write this as ln v over v0. So this is L, don't get confused it with I, it's ln natural log v over v0 equal minus bt over m. I'm going to take exponential function on both the sides in order to get rid of the natural log. So v over v0 is equal to exponential e to the power of minus bt over m. Rearranging the equation for velocity, because that's what we want the expression for velocity. So v0 is equal to v equal to v0 e to the power of minus bt over m. That's how we can get the expression for velocity.